and welcome to the industry track, the first day of TIPE. We're so excited to be here with you. I'm Melanie Lang. I'm the track lead here for you today. I'll be introducing the presentations and keeping us moving along. And I also have Liza Allison here. She's our digital ambassador, so she'll be also working behind the scenes. If you're a presenter, she'll check in with you and make sure that you're ready to go on stage, and also just be helping kind of move everything along. So if you have any questions, feel free to send either of us a chat and we'll do what we can to help you. There are some directions posted in the general chat in terms of how to use this platform and how to update your profile. So please take a look at that as well if you need any help with that. Liza, would you like to say anything before we get started?
You know what? I just wanted to welcome everybody and thank you all for attending. I think this is going to be a really exciting event, and I'm super excited for this first presentation with Hot or Not about the AM industry trends. I'm excited to see what this is all about.
It'll be an awesome presentation, I'm pretty sure, especially based on who we have kicking us off here. So I'm going to bring Laura and Stephanie on stage here. I want to introduce these speakers first. They are kicking off our entire industry track for this conference, and I couldn't think of two better people to do it as experts in the AM field, and they have just an awesome understanding, across the industry of what's going on. So we thought we'd have a little fun with it. Laura Eli is the Director of Programs at the Barnes Global Advisors, an independent engineering firm with over 150 years of AM experience. She helps customers on their AM journey, operating at the intersection of strategy, technology, and people. She spent the first decade of her career optimizing materials and processes ranging from rolling and annealing to friction stir welding and spin forming. Her heart sits with directed energy deposition. Woohoo! It's the driving force behind an $18 million CRADA with Oak Ridge and the creation of a new technology team for GKN's North American division. She mentors young engineers and passionately supports 3D printing and STEAM activities at her children's grade schools. Thank you so much for being with us, Laura. And we also have the amazing Stephanie Hendrixon. Stephanie is Senior Editor of Additive Manufacturing Media, a B2B publication where she covers new 3D printing technology and how additive manufacturing is changing production. Lately, she's been interested in stories involving unusual materials, non-manufacturers becoming additive manufacturers, and the pursuit of sustainability through AM. Stephanie is also co-host of the award-winning video series, The Cool Parts Show, as well as the recently launched AM radio podcast. Without further ado, let's welcome Laura and Stephanie. Take it away, ladies.
Thank you for the warm welcome, and thank you for the opportunity to be here. For starters, I started looking through the list of industry track and what's been put together, and I started getting really excited to be able to hear about these things. AM carries the promise of limitless designs with efficient and new material usage and rapid innovation. But juxtaposed with that is the use of AM in industrial setting. And in that case, we want it to be normal. We want it to be used regularly. We want it to possibly even be boring. And so we're going to kind of talk about that with our Hot or Not sequence. But this industry track is filled with all different topics, from fashion to transportation to health and recycling, what you can do with green lasers, and space and defense. So we're excited for you to join us as we discuss some of these industry segments, as well as some of the key trends in AM. But first, perhaps Stephanie can tell us how we plan to play Hot or Not.
Yes, so there are lots of different topics, different trends, different industries that are going to be covered here in the industry track. Laura and I have picked out 16 of them, and we're going to run through and rate each one hot or not. But just to quickly explain the scale here, if we rate something hot, that means that there's a lot of activity, it's growing, it's expanding, it's developing, we're still answering questions, we're still learning about that thing, and we're probably talking and hearing about it quite a bit. If we rank something as not hot, that's not necessarily a bad thing. That means it's reached that point of normalcy. It's matured. It's boring. It's happening, and we know that it's happening, but we may not be talking about it so much. There's not as much buzz around it anymore. And then we also have the option to rate something warm. This might be a previous hot topic that's cooling down. It might be something new that's coming in that's starting to heat up. So there is sort of a middle ground here as well. So for each of these 16 applications, markets, trends that we're going to talk about, we are going to kind of quickly summarize, give you maybe a couple of examples of what it is that we're talking about, talk about the drivers, why 3D printing is being used in that space, and then we're going to give our ratings. And I think Laura and I are going to agree on most of these, but we may disagree a little bit. We may have to talk about that. And we also want to encourage audience participation. So it's not just about my opinion or Laura's opinion. We also want to hear from the audience. So if you have if you want to weigh in on whether these are hot or not topics, please type it into the chat, and let's get some conversation going on the side here.
Excellent. You guys ready?
All right, so we will kick things off with tool and die. So what we're talking about here is 3D printing being used to make things like cores and cavities for injection molds, sand molds for casting, basically situations where 3D printing is building something that's going to form or shape some other type of material. So we've seen direct metal laser sintering being used to make molds with conformal cooling. Sand binder jetting has been used pretty frequently. I have mantle up there. That's sort of a newer technology, the true shape process where you're printing with a metal paste and then you sinter it, and they can pull things out of the sintering oven that can go directly into an injection molding situation. And so we see 3D printing being used for tool and die applications because of the geometric complexity that it enables, because of the assembly consolidation, makes it a little bit easier to build these complex geometries, and the opportunity to introduce conformal cooling and other potential like performance benefits in use. So I think we're ready to rate this one. What do you think?
I'm going not. I love that new areas are always expanding, but I think people have kind of figured out that tool and die AM, they've figured out, the schedule savings, the opportunities, and the good, sweet spots. But I absolutely love to see more development in this space with the expanded materials and new applications. So it's still a great space, but I think people are kind of done with talking about it because they kind of understand it.
Yeah, absolutely agree. I think it's become very well known that there are benefits to 3D printing tooling.
Absolutely. All right, moving on. Rapid fire. Space. Okay, so when we're talking about space, we're talking about launch vehicles. We're talking about maximizing a payload that gets taken up, and performance improvements. So some of the pictures that we have here are NASA, the Perseverance Mars rover has multiple 3D printed parts on it that are additively manufactured parts that are roving around on Mars right now. I think that's a word, roving. The bottom left hand is an example from Launcher. They're a small sat launching group. They have been using 3D printed parts. There's an orbiter propellant tank that's shown there. They've also done a shrouded impeller for their rocket engine turbo pump, working closely with Velo with their capabilities. And the last one that I put on there, the video that just played, was DM3D worked with NASA Marshall Space Flight Center and made this 10-foot tall, of course, I had to put a DED example in there. Later on, just of note, is NASA and JPL will both have presentations later in the industry track. So if you're interested in learning more about this space, we will definitely have that on the agenda. So I rate hot.
Definitely
hot. Yes. Okay, so everyone's in agreement there. I think it's really exciting to see the developments, and I think we're just going to continue to see more and more as people are kind of figuring out the mission assurance requirements. Okay, next category, aerospace, obviously not including space. I think when we look at this on the left-hand side of the screen, I put up pictures that everyone, if you've been in the aerospace space, you will have seen before. Ducting, we have the Norse titanium floor grid ducts. Brackets, we have the Airbus little bracket. We have things like the GE Leap fuel nozzle, all of those things. And those have been around for quite a while from an application standpoint. I will kind of highlight two areas, though, that Stephanie and I were talking about that are interesting and they're starting to move that would be in the general aerospace, and that's urban air mobility. So this is showing a Joby Aviation electric vertical takeoff and lift vehicle. They have made a comment that they will be using titanium structural AM components on this vehicle. And then also unmanned air vehicles and drones. Which again, sometimes those qualification and the safety requirements aren't quite as high, and you have this iteration and rapid design process that we're able to do there. So what does everybody think? Okay, we've got at least one not hot in there. Aerospace warm. Fair enough. I'm gonna say not on this one. And I think we are going to continue to see progress. It's just kind of more of the tortoise pace of progress.
Yeah, and I think like here it's a little bit similar to tool and die. Like there are some really well established technologies and use cases, and so like, but the benefits that 3D printing is bringing to things like drones and urban air mobility are very similar to the benefits that it's already bringing to other types of aerospace. So it's just sort of like getting into a new product or a new market that's kind of all within the same sort of family there.
Yeah, agreed. I will note that we do have a panel later on in the industry track that's AM in the U.S. Army and Aerospace. So that should hit more of this topic a little bit later.
All right, so we have fashion and consumer goods, and if you were in the keynote this morning, you already heard some really cool cutting edge fashion stories. But what we're talking about here is more direct to consumer products that are being 3D printed, mostly things that you can buy, you can purchase today. And so there are a lot of reasons that 3D printing is being used in the consumer goods area. And some of it is because of the way that you can size things precisely to fit a unique individual, the way that you can customize things. So that's the case for like the Atrex insoles there, the Fitzframes glasses, which I'm also wearing. You might also want customization that's enabled through 3D printing because of your personal taste or style. So like that's the case for the future of jewelry rings, which Casey Melvin is going to be speaking in the industry track, I think later today. And then there are other reasons as well where we see people using 3D printing as a way to get to a more sustainable product. So that's the case for Hylos. Those shoes are consolidated into just a couple of materials. They're much easier to recycle. They're also being printed on demand. Again, Gaia Galati from Hylos is also presenting in the industry track. And then there are functional reasons to use 3D printing as well. So like the Cobra Golf Club is an example where they chose this design as a way of reducing the twist in the club, so improving its performance, and also for the reshoring aspect, moving to metal 3D printing for this club head allowed them to bring the production closer to home, closer to where people are going to be buying it, closer to where it's going to be finally assembled. And so there are a lot of different ways that we see 3D printing being used in this space. And then, as Melanie said at the top of the presentation, I'm really interested in cases where people who were not previously working in manufacturing become manufacturers just because they had a great idea. And that's the case for a couple of the products on here as well. So 3D printing is a lower barrier to entry than something like injection molding. And so it turns out that a lot of designers and people who maybe aren't necessarily working in manufacturing right now come to 3D printing as a way to make this thing that they'd like to sell. So all that being said, I'm going to rate it hot.
I'm going to go hot as well. I think you're starting to get to more of the mass impact. I think it's still kind of in certain pockets. So it's not necessarily, I don't think it's reached its end destination yet, but I certainly put it on the warming up curve.
Yeah, absolutely. And I think a lot of, not necessarily the things on this slide, but there are some other products that are pretty expensive right now that are being 3D printed. And so I could see the cost coming down. And then some of these things like the insoles depend on a very specific type of scanner, like you need a pressure map of your foot. And so some of that scanning technology is not yet readily available. And yeah, so it has not reached its final destination. I agree.
Absolutely. Okay, our next topic is transportation. And I've done this broadly, so automotive and rail, all included within this. The example on the bottom left is the Zinger hypercar. Kevin it's Kevin Zinger, has Divergent 3D as well. And so they are doing toolless 3D printing of lightweight structures. And this is another one of those where you're seeing additive as a part of advanced manufacturing. They've got robotics involved. And this was also one of the drivers for the SLM Next Gen 12 laser machine, because they are wanting to get to the production volumes that are required for automotive industry. The other thing that we have going on in automotive is, of course, this move to electrification. So similar to our electric VTOL example, weight savings are a huge driver. You've got to offset, battery weight, and of course, being able to optimize for things like crash impact and other things are a big deal. On the rail side of things, there's actually quite a bit going on in that space as well. So we've got an example from Wabtec. They have a facility located at Neighborhood 91 next to Pittsburgh Airport. They're doing aluminum 3D printing for a variety of parts. And the other one that I put on here is Deutschbahn. So Stephanie Brickvidi will be presenting later on. She works with Deutschbahn, multiple parts there, one of which is braille on a handrail. So that one was pretty neat because, of course, you're introducing new functionality. And then she also was the starter for Mobility Goes Additive. And she also runs a Women in AM event in conjunction with AM Forum in Berlin. So I think this is an interesting space. There's kind of different requirements. Let's see. People are pretty much saying hot. Yeah. She's warm. Yeah. I'm in between. But since I'm binary here, so I can only go hot or cold. So what do you think?
I think similar to what we said for consumer, like it has not reached its final destination. I think there's a lot of question, like how far, at least in the automotive space, like how far in terms of quantity can 3D printing do? Is it ever going to get to the level of like an F-150? But there are definitely great applications out there. It is definitely warm to hot. I will concede that.
Fair enough.
All right, so dental. We are talking here about things like 3D printed models, mouth guards, 3D printed tooling to make aligners, dentures, all these sorts of things. You can see I have actually had direct experience with this. We did an episode of the Cool Parts Show where we visited Spectrum Dental, which is a dental lab in Columbus. I went through this entire workflow where I got my mouth scanned. They printed a mouth guard for me. And this is something that as the dental industry kind of gets more digitized, as more dentists start to use these 3D scanners, it's a pretty natural workflow to move from the 3D scan to the 3D printed device. And so this is something that I guess if I say any more about it, I will probably give away what my vote is. So let's go ahead and write it.
All right.
Not. So this is the episode that I'm talking about that we did was about 2 years ago, and at the time it only took about 2 hours from the scan to me actually putting this mouth guard in my mouth. So the process was already pretty mature at the time, and now there are even more printers and materials and sort of options for this. So it feels pretty mature to me, but I think maybe it's not as widespread as we'd like it to be, just because dentists don't necessarily have the scanning technology. They're not necessarily digitizing as fast as we might like them to.
Yeah, I agree. While I said not because I think it's found its place in a productive environment and people have figured it out. My daughter had her orthodontics recently, and I was pretty disappointed to see the plaster tray and the old school way. So it's not completely. Maybe we are a little behind here in the Midwest. Okay, our next category is medical, which is, of course, a broad category. So when we're talking about this, we're talking about the ability to customize designs. We're talking about improved patient outcomes. We're talking about optimizing performance. So some of the examples we have here are some implants. A nice picture from Tangible Solutions, who does 3D printed titanium implants for both spine and joint. They're leveraging topology, optimization, design work. We also see an incredible amount in the prosthetics. And going back to Anouk's, I mean, the combination of prosthetics and fashion is like this incredible next level of amazing and cool. But I think with those, again, the customizable bit is the big deal, and kind of the local on demand, able to, print and give people, these customized prosthetics same day or next day. The final one is an example. It's actually resorbable printed bone. So we talk about osseointegration for implants. This one, actually, the bone takes over it and it resorbs, and then there's bone in its place, which kind of just blew my mind. So I think so much exciting going on here. We have multiple talks we have one on pre-op and healthcare, AM in hospitals, bioprinting and biofabrication. So I really recommend you look and see where those are falling in the industry track. So I'm rating hot.
I'm going to dissent just a little bit. I think that standard implants, not so hot, like especially Tangible Solutions, like these guys have figured out how to do standard implants. It's really impressive. But I would say hot for custom implants, for prosthetics, orthotics, definitely, and bioprinting, just red flaming hot right now.
Gotcha. All right, we're rapid fire through here.
All right, we got to speed up here. All right, so construction. So we're talking in situ concrete 3D printing, like the Icon printer that you see there. We're talking prefabricated 3D printed structures, like what Mighty Buildings is doing. Possibly also things like architectural elements, like bridges, maybe 3D printed tooling for concrete. Construction is a space where 3D printing brings a lot of benefits in terms of sustainability. Like you can use less material if you're only putting down the concrete that you need. You're only building the wall that you need. You're not trimming a lot of lumber and like creating a lot of waste that way. Construction is another area similar to manufacturing where there is a skills shortage, a labor shortage. And so 3D printing allows for some automation, allows you to do less with the crew and the people that you have, potentially leads to safer work environments. And so, yeah, I think let's rate it.
Going hot. I totally agree.
Also, yeah.
I'm excited. Next time I go to Austin, I'm hoping that I get to see some buildings being printed. It would be awesome. Okay, so our next category is energy. So one of the examples we have is S.J. Jones from Siemens Energy. So she is holding a part where 3 parts were consolidated into one print for a gas combustion system. I think this space we see also, the prototyping ability and analysis. So a small scale hydropower test bed was done by Cadence, which is interesting as well. So you're looking at, optimizing and then taking that up. The other area, and I was just down at Oak Ridge this last week, which was exciting, is what's going on in nuclear as well. So they have a program called the Transformational Challenge Reactor, and this is where you can use new access to materials and speed that weren't there before, embedded sensors, all kinds of exciting things. And then the other area is oil and gas has multiple groups that are playing in finding their space. I think it's another one that's just going to continue emerging as far as those winning applications. We do have a couple of presentations. One is on how AM is disrupting the energy industry. And so, tune into that one. But I think we need to rate this one. Yeah, I really want warm on this one. Am I allowed to? I'll just twist.
Yeah, that counts. That counts. Yeah, definitely warming up for sure.
Gotcha.
All right, so sustainability. There are a lot of different ways that additive and sustainability can sort of go together. We've focused here on materials. There are biodegradable material options. There are recycled material options, like what GreenGate 3D is doing with PETG, like what 6K is doing with metals. Beyond the materials, there are additive also offers opportunities like assembly consolidation. You can use fewer materials, use fewer fasteners. You can make these really lightweight, optimized geometries, maybe make products that perform better, that are more durable. And so there are a lot of different potential ways that 3D printing and sustainability can work together. So to rate this, hot to warm, yeah.
Hot to warm, yeah.
Warm to hot.
I agree. I think they're figuring it out, and I think AM is a really good complement to that. So I think there's lots and lots of opportunities. And there is a recycling presentation on day 2, which is recycling of materials for AM processes as well. So
yeah. And I guess the big gap that I see here is that there aren't enough like life cycle analysis type things out there yet where you're absolutely sure that this 3D printed bracket is better than this standard machine bracket. Like we need studies, we need people looking at this. That's something that the AMGTA is studying, the Additive Manufacturing Green Trade Association, and I believe they're doing a presentation maybe tomorrow. So keep an eye out for that to learn more about this.
That's a good segue into our next topic, which is just advanced materials in general. I think it's really important to remember it's that material and process balance and what that creates. So whether we're talking about ceramic, this is a ceramic implant from Lithos. Fortify is really cool. They have, polymer, and they have metallic particles within there, and they are using a magnet to align those particles for specific performance. It's kind of amazing. We have carbon nanotubes with Mech Nano. We have continuous fiber printing with an isoprint and a whole bunch of others. So I think in this space, it's like, this is majorly hot. Okay, so I'm just gonna.
Yeah,
it's not just because I'm a materials engineer. I swear.
The chat is just scrolling by with hot.
Yeah,
So
we've just blown this space up. Okay, so we have agreements across the board.
All right, so next topic, all sizes welcome. And so what we're talking about here is additive manufacturing, like going to the extremes and everywhere in between. So we have the capability to do really, really tiny prints like what NanoFabrica is doing. This is an alternative to things like micro machining and micro molding, where 3D printing can be used to make the end product. It could also be used to make the mold. It can also be used for prototyping so that you can figure out the right design before you go through all of that to make a really tiny mold. And then on the other end of the spectrum, we have so many more options now for large scale, large format 3D printing, things like the big area additive manufacturing machine, the BAM, which was used to make this flight simulator body that you see from Additive Engineering Solutions. This is a case where 3D printing provided assembly consolidation benefits. This was part of a project with L3 Harris where they were trying to reduce the number of parts that the simulator needed from like 3,000 down to under 300. And they were able to achieve that by 3D printing, in part by 3D printing this body in just a couple of big pieces. And so there are really, really small options, really, really large options. And then another thing that I've noticed recently is sort of like more medium-sized printers where you have desktop printer companies scaling up to build bigger printers, and then companies like Cincinnati Inc. scaling down a little bit to do things like the medium area additive manufacturing machine, the MAM. So yeah, very hot.
Yeah, I think there's a lot of different ones, and I'm excited by all the processes that are coming out and what that enables from a, from an application standpoint. All right, we're moving fast now. Okay, so investing in AM is hot. It's burning hot. From a TBGA standpoint, we participated, I think, in 8 technical due diligence as a part of mergers and acquisitions activities just last year. So what's interesting here is it's across the entire value chain. We're seeing, a consolidation of digital partners. So sometimes that's additive and subtractive, software capabilities. We're seeing trying to, enable the digital flow. The other thing that we're seeing is a consolidation amongst contract manufacturers. So you got folks like AdMan and Beehive that are buying up basically manufacturing capability and combining those together. And of course, we see continued investment in the material and process space as well. So I certainly rate this one hot.
Definitely. All right, supply chain. We're almost to the end here. Supply chain is something that got thrown into the spotlight as a result of the pandemic, as a result of all these other disruptions. We in additive manufacturing have known for a long time that it can be this solution for distributed manufacturing, for expeditionary manufacturing, for building things, making things near the places that they're going to be used. And I think that a lot of OEMs and other companies who had not previously been interested in 3D printing started to see it as a solution as a result of things like the 3D printed swabs that were being made all over the place. Yeah, I would go ahead and just rate this one hot. I think this is something we're going to continue to hear about for at least a few more years here.
I absolutely agree. And we're going to go on to our last two categories here. So people and skills, I do want to mention how great additive manufacturing is for getting children and people that are, in the K through 12 range excited in manufacturing in general. So I think it's a great recruitment tool to a manufacturing. And within the DoD, there is activities going on to support the development of the workforce. And I'm kind of skipping over categories, but I'm going straight to the last one here. So designing with AM, I feel like this is a perpetual hot topic. I think it probably will remain a hot topic. And I think the other bit is acceptance of AM as a part of the advanced manufacturing family. But when we're talking about complexity, fluid flow, lightweighting, part reduction, cost customization, all of these things, so excited. The one that I wanted to highlight here, I don't know if people have seen this. I found this. It was called, it's a art installation called Digital Grotesque. And it's a full-scale 3D printed grotto. So it's like 7 tons of sandstone structure that's been 3D printed. But what they did was they did computer design that was trained to elicit human response. So you want to talk about like the intersection of software and hardware. This is just like mind-blowingly interesting to be that. So official last rating for us is hot on this one.
We made it.
We made it.
All right. So we rated most of these, a lot of these hot. And that is because additive is still very much finding its way. We're still finding the right ways to use it. I do want to reiterate here at the end that if we said it was not hot, that's not a bad thing. That just means it's matured, it's established, it's getting to the point of being normal and boring the way that we talked about at the beginning. So I want to thank everybody for joining us here at the kickoff of the industry track. If you want to reach out to me or Laura, our contact information is up here, and be sure to stick around, check out all of these great presentations in the industry track. We covered a lot really fast in this presentation, but there are so many opportunities to learn throughout the TIPE conference.
Absolutely. And I'll just say TBGA has sponsored some AM certificates. We're going to do those scholarship awards on Thursday, and feel free to visit us at table 3.07 on floor 3.